Good afternoon. I'm Dave Rosenberg, CTO at DB CyberTech, the leader in predictive data loss prevention for databases. Our mission is to provide unparalleled visibility into structured data in motion for both security and compliance. Put simply, you can't protect what you don't see, let alone prove it. As anyone watching the news knows, structured data is the Gordian knot at the heart of data security and compliance challenges. Just a couple of recent examples. Earlier this year, Sachs and Lord & Taylor's parent company, Hudson Bay, discovered a loss of 5 million records of credit card data. And as scary as that sounds, it was just a drop in the ocean compared to Exacta's leak of 340 million records of personal information, just a few months later. If we're to meaningfully address such breaches, the ability to know what important structured data we have is absolutely fundamental. We're here today to discuss our revolutionary capabilities for discovery and classification of structured data that are the key to this problem. Next slide, please. By the end of this webinar, you'll understand the value of intelligent and autonomous discovery and classification of strategic structured data. I'll also describe the key technical capabilities you'll need to implement these ideas and how our solution for structured data in motion differs from any other you'll see. We'll give a brief demonstration and conclude with a gift for your attention and consideration. Next slide, please. Let's start by understanding why visibility is so important for structured data. When businesses collect high-value data, the vast majority is stored in databases, making them the source for extremely rich, high-valued information. If data was money in a bank, databases would be the vault. Visibility tells you about the greatest concentration of high-value data in your environment. Unfortunately, this concentration is well understood by bad actors, which is why invariably most significant breaches resulting in critical data loss involve direct access and compromise of critical databases. Just in my own backyard, the Sacramento Bee lost 2 databases in June, totaling nearly 20 million records of sensitive personal information. It's simple. Hackers go after databases because that's where the data is. Put another way, they're telling you what you really need to protect. As a consequence of this concentration of high-value structured data, when new regulations to protect this information come out, you can bet they directly apply to databases. As we discussed in our last webinar, the GDPR presents a host of challenges to data processors and controllers just to get and stay compliant. But the GDPR is the tip of the iceberg. Many other countries and local governments have been inspired to roll out their own data protection regulations. As we showed last time, visibility is the key to efficiently becoming compliant and staying that way by design. Visibility can also tell you about the risks you didn't know you had. Most organizations have a shadow IT, infrastructure they don't know about and don't understand, because officially it doesn't exist. When the shadow IT includes databases with high-value data, you're exposed to unmitigated security and compliance risks. As you can imagine, managing structured data could require a lot of resources and attention. You need to identify and track your high-value data, protect it from threats, stay compliant with evolving regulation, and maintain full visibility. On top of that, structured data environments are typically highly complex and difficult to manage from both security and compliance points of view. To make this tractable and efficient, you must allocate scarce security resources to the structured data assets which matter most. Next slide, please. Let's take a moment to highlight a pernicious data security problem. In virtually every engagement we've had at DB CyberTech, we found databases our customers knew nothing about. Sometimes there are systems that weren't adequately tracked through acquisitions. Other times, employees simply worked around established policy. Typically, we find 20 to 50% more databases than customers anticipate. To make matters worse, that 20 to 50% is dynamic, continually evolving over time. This is a real problem. It's simply axiomatic. You cannot protect what you cannot see. If data is being staged for exfiltration, it's a safe bet it's in an undocumented database. If an undocumented database is still connected to the secure portion of your network, you're likely out of compliance with regulation. So how do you start to address data visibility? Next slide, please. Let's define a few broad categories. We're talking about structured data, so database assets are what you need to discover and classify. Databases come in different dialects and contain collections of objects such as tables, users, and roles. To communicate with them, clients must know where they are, not just by traditional IP address and port, but also by service name. This is where most available solutions stop. Given expert knowledge of some specific corner of your database infrastructure, scanning tools can interrogate individual databases about their context, yielding a backward-looking snapshot in time. For continuous discovery that enables security and compliance, you need much more. You need to answer some classic questions. Who is accessing the data? How are they doing so? When did this occur? In other words, you need to understand the client-server conversations in real time. Next slide, please. But how do you do that? Let's consider our approach at DB CyberTech. Next slide. First, consider structured data asset discovery. This is not a one-time scan, nor do we assume anything about the networks we listen to. Instead, we continuously monitor and comprehensively decode client-server database conversations across a wide variety of dialects and protocols. In this way, we discover who is talking about what. Next slide, please. There are a few crucial aspects to getting this right. We are fundamentally non-intrusive. This means we have no agents, we do no scanning, and we are never in line. We examine a copy of your network traffic, so we have absolutely zero impact on production database activity, the lifeblood of IT. This also greatly simplifies deployment. Since we can do no harm, there's also no harm in sharing all your database activity with us. There are some nice benefits to this approach. By not relying upon expert knowledge of your infrastructure, we require minimal assumptions about where structured data might exist. That's how we find undocumented databases, perhaps within your shadow IT. This isn't magic. We simply recognize database conversations for what they are, on the fly, and regardless of their endpoints. For example, we automatically discover databases communicating over non-standard ports. Another benefit of our passive approach to discovery is its continuous nature. While simple network monitoring can give you some limited insight into who is talking and where they are on your network, only because we decode SQL conversations can we see what they're talking about. Fundamentally, we understand SQL in all its glory and in its various dialects, so we know the meaning of each and every statement reading and writing your databases. When you marry this with near-perfect knowledge of database services, their clients, login users, and other network information, you get a rich and rapidly evolving picture, a 360-degree view, if you will, summarizing all of your database conversations. Next slide, please. It's important to understand the advantage of tracking data in motion over data at rest. Not only can you understand in real time what you have and who is accessing it, you can also see how your environment is changing. Are there new databases being spun up? Has someone accessed your high-value data in a new way? In contrast, seeing only data at rest by definition, is backward-looking. It's predicated upon knowledge of your physical database infrastructure, but how do you scan what you don't know exists? Not to mention that scanning is invasive, often detrimental to performance and reliability, and expensive. Worst of all, scanning data at rest simply cannot tell you how your high-value data is being used. Next slide, please. This is the very thing we enable by discovering application-to-database interactions. Structured data environments are complex, largely because they contain large numbers of discrete conversations which tend to evolve organically over time. Next slide, please. With non-intrusive continuous discovery, we go far beyond the traditional network map. Instead, you get an access map, literally showing you how your environment is interconnected with instant visibility into when, where, and how your data flows. This view is essential to characterize your fundamental security risks. Every time your data moves within your environment, there is some degree of exposure. By analogy, ask yourself, which is more dangerous, a parked car or a moving one? That's the critical difference between data in motion and data at rest. You must be able to answer the questions, how is my data being used? Who is accessing it? And where are they moving it to? And when? Next slide, please. With application-to-database interactions, we have a wealth of interesting information to explore. This won't necessarily tell us where high-value data resides. For that, we need data classification. Next slide. In a structured data environment, classification boils down to an exercise in translation. The input is richer than you might expect. Fully decoding conversations yield not only database queries, but their meaning. The objects they access, the nature of the potential manipulations they perform, and a variety of human artifacts such as identifier names, comments, and the like, necessarily left behind by human programmers, often betraying the nature of the data. In order to communicate the meaning of the data to applications and their users, queries also include various labels, identifiers, and other metadata. We use a broad mix of custom natural language processing and semantic analysis to map between SQL semantics within the metadata we examine and natural language communicated to our end users. That is, from database artifacts to human meaning. We then discover human language-defined semantic terms in context within a sophisticated, fully extensible classification hierarchy. This flexibility is key. High-value data is often in the eye of the beholder. It depends greatly upon context. High-value data in your environment might not be sensitive in mine. So, any data classification technology has to address this variability. We allow our end users to directly express what they consider important in natural language. And naturally, we give them a good start with our standard classifiers. The result looks like this. From a sea of SQL statements spread across your data infrastructure, both often measured in millions of elements, we pull out relevant facts. For example, that streets and mailing addresses are being processed within a specific database and a small set of applications. In this example, those might tie back to address data, a category of potentially sensitive data defined in a classifier tree. In this blizzard of activity, you can effectively evaluate each client-server interaction and answer the questions, where is my sensitive high-value data? This happens automatically, over and over again, many thousands of times per second, spread over tens of thousands of discrete conversations, meticulously recorded for review and investigation. Next slide, please. This is what we mean by continuous. We leverage the very technologies that make structured data environments complex in order to make them comprehensible and manageable. Every company has a finite budget for security or compliance resources. We enable you to align those resources judiciously so your people can proactively and efficiently manage risks associated with this information and not a pile of complex technology. As we look to the future at DB CyberTech, we can anticipate how we will correlate our data classification capabilities with a number of interesting important threat vectors, and we'll continue to tighten the integration between structured data classification and the compliance and security value we deliver. Next slide, please. To complete the picture, we should talk about predictive threat detection. Once you understand a structured data environment and what's important within it, you can readily protect it before data is lost. Next slide. As I've said, data at motion is data at risk. To measure that risk and ultimately to mitigate it successfully, our predictive threat detection targets malicious intent. It's now well understood that the dwell times between data compromise, that is, egress from databases, and loss, egress from organizations, are on the order of weeks and months. And this is best understood as reconnaissance, something right out of Sun Tzu. We exploit this fact, recognizing unusual behavior specific to highly sensitive data at the first point of compromise, so we can alert our users to take action well in advance of its potential loss. Next slide, please. That means we can ask pointed questions like, is it normal for Dave to access the sales leads table from his wireless computer before he exfiltrates the whole thing? While we're proud of the underlying machine learning which powers our state-of-the-art anomaly detection, for this webinar, I'll just point out the pivotal role discovery and data classification play in the reliable threat detection we provide. Discovery puts threats in context. For example, suppose your development and production environments are highly connected, a situation much more common than you might expect. This implies an inherent degree of structural risk. As a result, you could be suffering from repeated inadvertent development access to sensitive production resources. Discovery and the application to database mapping can help illuminate this fact, pointing to the structural changes needed to improve your overall security posture. Data classification helps focus our predictive modeling and threat analysis on just your most critical assets. Human-driven anomalies will always be with us, but your attention must stay on that which matters most. Next slide. As you can see, we're making security and compliance consumable and dramatically more useful while hiding the wealth of complex and deep technology required. Next slide. Now is a good time to concretely demonstrate what we've been talking about. I'll show you the DB CyberTech security and compliance solution for discovery and data classification after it has been exposed to a typical structured data environment for a few hours. Along the way, you'll see what it's like to review a real-time inventory of your database services, how they are accessed, what kinds of high-value data might exist, and review where that data is found. Let's switch to the demo. Let's begin our demonstration with inventory. Nobody relishes taking it, but this one screen turns out to hold lots of surprises. With no configuration, out of the box, we simply show the structured data activity we see on your network. It turns out more than almost anyone expects. If you tell me there are, say, 1,000 databases in your environment, there's a pretty good chance we'll see closer to 1,100 or 1,200. Sometimes lots more. We spend quite a lot of time on this screen in the first few days of engagements, not because it's filled with colors and flashing lights, but because it simply contains information our customers have never seen before. Once you know your inventory of database services, it's time to take a look deeper into who is communicating with them. If there's an important database service you'd like to highlight, simply filter the list to any database service to see which clients access them and how active they are when they connect. We find our customers return frequently to this screen to answer their most basic questions. Another way to understand this same information is to visualize the answer. If you group your clients on the left and your database services on the right, and then draw lines reflecting dialect and activity by color and width, you'll get a picture that looks a lot like this. This is what I meant earlier when I said you get more than a network map, but an access map. Let's see what one of these connections is up to. Here we see the queries used by this specific connection type. Put another way, here is data in motion. Data classification is built right on top of our discovery function, and like the rest of discovery, there is a lot you can drill into. But right away, you can see how much of your structured environment has high-value data, and how that information is classified. In this example, there are 36 database services processing high-value data spread across 839 services altogether. Next to that, we see there are 133 connections to those services involving high-value data, and 364 distinct queries we've seen implicating this information. If there were a large increase in any of these basic counts, that's a strong indication of a substantial change in your environment, one most definitely worth understanding. On the far right is a visualization of the different kinds of high-value data automatically found in your environment. We also allow you to customize what is considered high value and, in fact, the overall nature of the classifier. While we supply a basic definition, each customer's true definition depends upon their context. So, for example, say you know that the term invoice in your database carries sensitive payment information. You can simply add that term to your classifier and then refresh to see your results. Since we've scoured the use of every word in your environment, it's quick to see that there are in fact 2 new database services we need to keep an eye on. The full detail of our findings are listed below the summary as a searchable and drillable set of screens. To share these results, simply export to PDF or CSV to capture the complete list of database services where your high-value data resides. As you can see, significant complexity and detail can still be easily digestible and highly actionable with the right visibility. This concludes our brief demonstration. Here's the net of this presentation. DB CyberTech's discovery and data classification solution enables real-time monitoring of all your structured data in motion. This lets you automatically and continuously discover and classify high-value data assets. As a result, you can efficiently isolate and control your most important information for security and compliance. No other technology can listen to and understand the database conversations comprising your enterprise at scale with such great accuracy and detail and in real time. I'd like to thank you for taking the time today to better understand what intelligent discovery and data classification are all about.
Thank you. At this time, we'll begin the question and answer session. If you'd like to register a question, please press the star followed by the 1 on your telephone keypad. If your question has been answered and you would like to withdraw your question, please press the star followed by the 2. If you'd like to register your question online, you may do so by using the chat feature located in the lower left-hand corner of your screen. Please stand by for the first question.
Okay, we've got a question from Fred. He asks, when you say how data is being accessed, what do you mean by read or write? I think the best answer is that we detect the nature of the SQL statements we see via kind of a semantic analysis. This is very similar to what would happen in a relational database, for example. The SQL comes in, it's taken apart from several points of view, and ultimately we assess a meaning to it. So what we're doing is we're recognizing, for example, that select statements access database tables for read generally, or that an update statement accesses a database table for write. And there's many other examples. There's actually quite a few kinds of objects, and but read and write is a pretty common idea across those. See if we got any more questions here. Okay, so from Susan. How do you get a database table name or database column name from data classification without an agent? And it's a similar answer, actually. We capture that client-server database traffic, as I discussed above, from the network. So at the network level, of course, what we're seeing is a copy of your traffic. And because we understand the detailed protocols beneath the various database vendors, and there's nothing standard about that, we pull that all back together. And so essentially, we're seeing the conversations that all the database clients have with their servers. One of the things that comes out of that analysis is the SQL itself, and that's actually what we're analyzing. Sam says, what do you mean by we understand SQL? Are you using signatures of common SQL queries? And I have to say absolutely not. There's really not that many common queries that we could build into the product, but in reality, it takes apart SQL statements the same way a relational database might. And basically, by a semantic analysis, that's how we decide what they mean, and that's how we decide how to assess whether they're sensitive or not with respect to a classifier. Steve asks, how difficult would it be for your data classifier to find sensitive data types that are unique to just our company? That's a great question. So the long and the short of it is we have a classifier that we built for you, a generic sort of personal information classification system for PII, basically. But that's not really wired into the product. That's totally extensible. I can describe several ways that might be done. So one is you can tell us about specific abbreviations that might be utilized in your SQL statements and how those expand to terms we might expect. So a good example would be when you're taking apart SQL identifiers, of course, programmers tend to abbreviate in standard ways what it is they're talking about. They might call personnel data something like PRSL, DATA, just to save some time, right? Those are the sorts of abbreviations that tend to be application or locale specific. And if you tell us what that was supposed to be, you can actually help the system figure things out. Of course, it has lots of ways of doing this inferencing system, basically using inferencing to do that by itself, but it's always useful to extend if you need to. Another aspect is you can actually tell the system about completely new concepts, right? So say there's something just completely specific to your organization. It doesn't even have a word, per se, that we might match to. Well, you can tell us what that is. You can give it a meaning. And more specifically, once you've got that defined, you can say, and that should be classified as X, right? And the classifier is basically a tree. So you can say how it should be classified and what it's supposed to mean. And then basically by substituting those definitions, we'll pick up your local requirements. see if we've got any more questions. Oh, there's one. Actually, it's more about the demo. No, I think that did it. So I think we've completed our questions, comments. Anything else coming? Well, I want to thank everybody for attending. Thank you.
Perfect. Thank you, Dave. And ladies and gentlemen, thank you again for your participation on today's conference. And you may now disconnect your line.